All right, welcome back, Math 30-2s. We're on lesson 6, unit D, and we're going to talk about laws of logarithms today. Okay, investigating the product law. So we're going to investigate, and then we're going to make a general law for the product and the quotient. Just like there are the laws for, sorry, I'm just realizing the light is like kind of crappy. It's a little bit better. Just like there's laws for exponents, there's laws for logarithms. So if we were to actually evaluate these, okay, we know that this, oh yeah, I was gonna show you another cool trick. So if we have log base of whatever a is to an argument that's the same, okay, whatever the exponent is, that means that this overall log is equal to x. So for example, this one right here, 16 can be written as 2 to the power 4, okay, which would be the answer. So let's just look at this one. We would do this one right here. So we do log base 2 16 is equal to v. 2 raised to the power of v is equal to 16, which we know 16 is 2 to the power 4. Get rid of the bases, and there's our power, okay? So this right here, all I'd have to do is rewrite it as log 2 to the 4 plus log 2 to the 3, and that's going to equal 4 plus 3, which is equal to 7, okay? So then let's do the same thing here. Okay, 16 times 8. So then I'm going to use my exponent laws again here too. So that's 2 to the 4 times 2 to the 3. Since these are being multiplied, they have the same base. We would add those exponents there. So then that's going to give me log 2. I'm just going to separate this here. And then 2 to the 4 plus 3 is 7. And then using my law from before, that's equal to 7. So I see that if I split up and take the sum of my logs with the same base, it's the same as multiplying their arguments here. So let's do the same thing over here. So log base 3, and then I'm going to write 27 as 3 to the 3, because that's what it is, plus log base 3, 3, and so that's, I'm just going to write a 1. Okay, so then that's going to be 3 plus 1, which is 4. Okay, and then same idea here, log 3, so this is 3 to the 3 times 3 to the 1. I would add those two, the exponent laws. Okay, and then once again, I've got the same answer. Okay, so if I write it as like log whatever the base is, and then let's go x plus log by, we see that it's equal to if I multiply those two. So that's like the general statement there. Okay, now let's look at the quotient. So quotient, of course, means division. So I'm going to use my same practice with the converting these. So that's going to be log 2 to the 4 minus log 2 to the 3. So that's going to be equal to 4 minus 3, which is equal to 1. Okay, this right here, well, I can simplify that. 16 divided by 8 is just 2. So then that's going to give me log 2, which is technically to the 1, which is equal to 1. Okay, so we see that one's true. And then over here, log 3 to the 3 minus log 3 to the 1. 3 minus 1 is equal to 2. And then over here, 27 divided by 3 is 9, which can be written as log 3 to the 2, which is equal to 2. So then for my general rule for the quotient, I would see here that if my base is the same, of course, so if I subtract those two, that's the same as if I have the argument, those two arguments being divided. So then that brings us to, yep, here is the product and the quotient law. You will get these on your formula sheet. Okay, so let's do this now. Evaluate the following using the product law or quotient law. So we saw up here that when we have it in the quotient law, like it's easy to just divide and simplify. So let's do this here. So we could just write this as log base 2. So then 12 divided by 3, which is going to give me log base 2. 12 divided by 3 is 4. Okay, so that means I can write that as 2 to the 2, because 2 to the 2, or 2 squared, is 4, which means right there, that's equal to 2. Okay, this one right here. So we're adding these, and then we're going to divide that one. So this would be log base, and this is, you can do this because it's all the same base. So we'd have 9 times 8 divided by 2. Okay, that's going to give me, so like this right here, 9 times 8 is 72 divided by 2, which is going to be 36. Okay, and then 36 is 6 squared. So I would write it like this and just say 2. Okay, so we evaluated those logs with the laws. Okay, over to page 236. All right, Aki and Annette were asked to use the laws of logarithms to write out that whole log expression as a single logarithm. This is like a classic example of what you would need to do. Aki grouped the logarithms and factored out a -1 before applying the laws of logs. Annette chose to use the law of logs from the beginning of the question. Complete their work. Okay, so it's weird that he started down here, but oh well. All he did was rewrite this out. He factored this out. So let's just we should start with what the original was. Okay, and then he did that, so he factored out this negative right here so that he could group these. So then right here he used the product quotient law, and then same thing here, product quotient law. And so then 10 to the 75, and then this is going to be the quotient because it's subtraction. And then I'm going to have 2 to the 3 down there. So then this right here, 10 times 75 is 750 divided by 6. Okay, well, that looks like a B, so I'm going to do that. And then 750 divided by 6, I think, is 125. Let's see. 750 divided by 6. Yep. Escape is 125. Excellent. So then log x, and so the argument is 125. Okay, let's go over to a net solution here. So log 10, so we start off the same, okay, and then she just used them from the beginning. Okay, so this right here is being added, so that's going to be 10 times 75. Okay, and then so we're minus 2. Okay, well, minus 2 puts me down here. And then we're minus 3, which puts me down there. So you can also just think of it that way. Okay, I like doing it this way just because I like the extra, I don't know, my brain likes this. But if this makes sense, then go ahead and do that. So then we're back to 750 over 6, which once again simplifies down into 125 as the argument. Okay. All right, let's look at the next class example. So use the laws of logs to write all of this. So it's exactly the same setup, right? 2 things being added and then 2 things being subtracted, and we want it as a single logarithm. Okay, so then let's do this. So from here, we're gonna have log base b. Okay, these 2 are getting multiplied, so 2 times 3. Then I have a -6 and a -8. Okay, and then I'm going to simplify. This is going to be 6 over 48, which is the same as 1 over 8. Okay, so log base b, 1 over 8 is our single log. So now a part B, it says evaluate if our base is equal to 2. Okay, so log base 2 of 1 over 8. Okay, well, 1 over 8 can be written as 2 to the -3. The negative because it's the reciprocal, and 3 because that's what gets you 8, which means, boom, oops, don't forget the negative. The answer is -3. Okay, next example here, the expression is equivalent to. Okay, so I'm adding those, so that means those are getting multiplied. So I would just write log 2, and then I multiply x times 2x. And then since this is dividing, the quotient law states I'd have that x squared there. So now I have x times x, which gives me x squared, divided by x squared. Well, those are going to cancel out, right? So then I have log base 2 of 2. Well, that's just going to be equal to 1, right? Because there's technically a 1 there. So there's my answer. So then from there, you can do questions 1 to 6. Okay, one more page. Investigating the power law. Okay, so we did the product, we did the quotient, now we're going to talk about the power law. So remember, if we're talking about exponents, the power law would state that we would be multiplying those, okay? All right, so by writing 2 log x as log x plus log x, so that's like saying like 2 apples is an apple plus an apple, okay? That's where this is coming from. So if we write it, so we're going from here, okay, and we want to show that it's equal to this. So I'm just going to use my product law here now. Those are being added, okay, and this is obviously the common log because nothing's there. So then if those are added, I multiply. So then that's going to be equal to that log x squared. So we see that 2 log x is equal to log x squared. Okay, let's do it for this one over here as well. So this 3, so that's going to be equal to log 2a plus log 2a plus log 2a. I have 3 of the same thing. I would use my product law and multiply all of these arguments, a times a times a, which of course gives me a cubed. Okay, so what we're seeing is the coefficient out front here, we can write it as a power on the argument. So if I have this expression right here, this is going to be equal to writing log bc, and then this a can go there, which is what we see as our power law. So we've done the product, the quotient, and the power law. All 3 of them are available to you on your formula sheet. Okay, let's look at these last couple of examples. So it says write the following in the form of n log x. So that just means we don't want any kind of exponent on our argument. We're going to write it in front. Okay, so we would use the power law, okay, to do that. That one's easy. This next one, remember that is equal to our rational exponents would be equal to a half. So this would just be equal to 1/2 log x, okay? And now we're going backward, or not backwards, but the other way, where we're gonna write that up onto the exponent, okay? And then this one, x to the negative 1/3. Okay, and then example 7. So once again, it says write in the following in the form of n log bx, and then evaluate. So evaluate always means like we want an actual answer. Okay, so we want to move this 2 out front. So it's going to be twice of log 2, and then I'm going to write 8 as 2 to the 3 because I know that that's going to cancel out, and then I'll have 2 times 3, which is equal to 6. Okay. This one right here, okay, well, I can, this one right here, I could bring the 3 out. So it's going to be 3 times, so I'll put a multiplication there just so I know. So that's going to be 18 log 49, and then 7. And so this one, so this is what I would do. I would recognize that 7. 7 is equal to if I had square root 49, right? Which is going to be 49 raised to the power of 1/2. So I would change the base because then I can use that fun simplification and just have 18 times 1/2. So the answer is 9. Okay. That one's a little bit trickier because you have to think kind of backwards, but that's okay. Okay, this right here is 7 raised to the power of 3/2. So that's the 3. The over 2 is the square root. So this is what we're going to be multiplying with our power law. So 6 times 3 is 18, divided by 2 is 9. And then I have log 49, 7. Okay, and I could do the same thing there where I write 7 as 49 to the half, and then those cancel out, and I've got 9 times 1/2, or just 9 over 2. Okay, and then this one, I mean, this is just going to be equal to n, right? Because it would cancel out, but they did say that they wanted us to do this first, so I would use the power law, and so I would just put a 1 there and say, like, that's going to cancel out. N times 1 is equal to n. All right, one last example. Okay, so I've got a couple things going on here. I've got a quotient law and I've got product law. So they're saying to determine the value, so evaluate if P over Q is equal to 8. So I've got P and Q separate. I need to put them together, okay? So this is 3 and 3, so I'm gonna just put that 3 out front here, and then these would get multiplied, or God, not multiplied, divided, quotient law. Okay, and then I would do that to show that the 3 was going there. Okay, P over Q is 8, so then I'd say 3 log 2 is 8, which I know 8 could be written as 2 to the power 3. So that means I'd have, so I'm just gonna write it because I got a lot going on here, 2 to the power 3. So that gets canceled out, and I got 3 times 3, which is equal to 27. Okay, and that is lesson 6, and you can get started on your assignment.